Hey everybody, how are we doing? We got so many people here. We got 10 people watching. Kayla's here for the first time. Tiffany, Mohammed. Mohammed has a question. I have some questions about our group app and wondering would it be best to send you the file on Discord? Yeah, send me the file. Remember, always start out small. So Mohammed, start out small right there and find those errors. Every time you have a little error. Haley, good to see you here. What questions do people have? It's pretty much open floor right now. Mohammed will be sending me the work that they have. We'll be taking a look. So I might have to do that later. We have to end a little bit early today. I have a meeting about a big presentation we're doing. Really excited. I'm bad at keeping secrets. Can you do the histogram visualization too? Let's start with that. Let's start with how to do the visualization. So I'll make the histogram here. Let me pause this. And here is a really good video on it. BAS assignment 1. Which one? 7 and 8 on assignment 1. We got some BAS here ready to do some there. So let's put Viz 2 full help. Yeah, let's do that. So you watch the video and can't figure out how to get the chart. Let's do that, Haley. Great question. Here we go. Let's give some full help on how to do the visualization. So 2 seconds right here. We're going to hop into this. This is a new topic. How to do visualization 2, the histogram. Let's take a look at visualization 2, histograms. Let's do this. And so here we are on visualization number 2, making a histogram. For a histogram, we need what kind of data? 20 points in the chat if you know. 20 points to start. What do we make histograms of? We got some more questions on the rain. No rain. Every good question right here. What do we make histograms of? Very good question. Write this down if you don't know it. Switch it. Here, I'll give you a hint. If you don't have this yet, Kayla right there, 20 points. Getting those office hours points. If you don't have this written down yet, I'm going to pause the screen here so you can see it. I'll find it here in just a second. Have this written down. We'll be seeing this more. Quantitative. Yep. You can see up there in the corner, histograms are univariate quantitative. So if you're making one histogram, it is univariate quantitative. So make sure to have this down right here. It's a review of all the graphics we've been covering. If you were in the morning class, we did mosaic plots, contingency table. Those are like your top 2 right there. And those are bivariate categorical. So don't worry if you get questions wrong here. This is the practice. We like to say get things wrong in class to get them right on the test. I'm throwing everyone some 50 points right here. Haley, Sarah, and everybody practicing. That's what we want to do. So let's go right here and make a histogram of the text per day that people have. We'll go here to analyze distribution. Don't use graph builder for this. Don't use graph builder for this. Don't use graph. Someone probably did graph builder like, oh no, don't use graph builder. Don't use graph builder for this. Don't use graph builder for this one. The other ones you use graph builder on. So we're going to go here to analyze distribution. And under analyze distribution, we're just going to click this quantitative variable. Now make sure it's blue. If it's not blue, then you're not doing quantitative variable. Make sure to do the one in the assignment. Double click. It's now in the Y columns. You could drag and drop too. It's already over there though. We're going to click OK, and then we're going to hit here to the top axis and go to stack. That's going to put it in horizontal layout. So now that this is in horizontal layout, it's just easier to read. I also like to extend this a little bit, makes it easier to read also. So with this right here, we have a pretty good graphic, but let's go here to the red arrow where all the options are at, histogram options, and let's put a count axis on this. The count axis is going to show us the counts of how many observations are in each bin. As you can see, there's only one person over here, one person here, and just other individuals over here. Error message. Mohammed, you know what's so interesting, Mohammed, that you see how that relates to this? It looks like your variable that you're using might be categorical or not the right class. So it looks like the variable right there doesn't have the right class. So we'll have to take a look at that, probably Discord or email it to me. And the variable must be quantitative, which is seen as in R as numeric. So when we look at this right here, what is going to be the proper measure of center and spread for this distribution? What is the proper measure of center and spread for this distribution? What is the proper measure of center and spread for this distribution? Mine has a cat and whiskers. Yeah, so it'll do a box and whisker above it. It'll do a box and whisker up here. That's perfectly fine. Should look something like this right here. And so my distribution right here, if we look at the shape of it, is very, very skewed. Very skewed to the right. Right to the high, left to the low, whatever way the tail goes. So this is very, 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 very right skew. Very right skew to the high side. So this is skewed to the high side. This is the low side. So since this is skewed to the high side, right here, we would use the what and what to describe the center and spread respectively. One thing I want to point out about the output is your output's kind of a cheat sheet. On the output, you'll notice right here that we have the mean and standard deviation next to each other, almost like they go together, and also the median and the IQR next to each other. That's because, let's put this one in red because it's not the right one. This is a measure of center. This is a measure of spread. And this distribution being skewed, what will we use right here? I guess a little hard to, that's the measure of spread. So what should we use since this distribution is heavily skewed and we don't want outliers drastically altering the center and spread? So since this distribution is heavily skewed, we should use the what and what. IQR as a measure of spread, correct. And then what is the IQR paired with? What is the IQR paired with? The IQR is paired with. Yeah, and if you have an issue when you do the assignment, like if something comes out different, just let me know, and I've corrected a few people's. One person Discorded me and said, hey, Brian, I did this right, and it gave me the wrong answers, and I got 100. So sometimes it's just on these 1 or 2 questions the way Jump calculates them, which is a real bummer. Median, great job, Jonathan, right there, earning everyone another 20 points. Jonathan, you are correct. What do we see right here with the maximum, the Q3, the Q2, which is also the median? What is this right here? I've highlighted here 5 different things. Who knows what these 5 different things are? If we talk about these 5 different things right here, the min, the Q1, the median, because this is the first quartile because it's 25%. This is the third quartile because it's 75%. That's the 5-number summary. How do you know if it's paired with the median and the mean? What's the first thing we look at? Sarah, great question, 20 points. To know if we're using the mean or the median or the standard deviation or the IQR, what's the very first thing we look at? The first thing we look at over here is the what of the distribution. The shape. Justin, great job right there. Justin, some 474, 475, helping out with some big points right there. Justin is very correct. We look at the shape first, and after we determine the shape, if it is normal, we'll draw some help up here. If it's normal, i.e. symmetric, unimodal, or mostly symmetric, we'll use these. If it's skewed over here, we'll use these. So I've kind of really drawn a help sheet right here showing us that the center and spread, respectively, for skewed distributions are going to be the median and IQR. But for more normal distributions up here, you know what? Let's make these the same color as we did the S and C down there. For more symmetric or more normal distributions, we're going to use the center and spread of mean and standard deviation. So we've basically drawn a cheat sheet right here. Now, when you interpret this is help right here. Here's how I would interpret this. So listen to how I'm going to say more than just median is this, IQR is this. So listen in. Everyone listen up. Here we go. The interpretation I would say if I was writing this up is I would say, the distribution of students' text per days is heavily skewed to the right. We also see some extreme outliers of people who said they text 1,000 texts a day, 800 texts a day, and some more mild outliers in the 2 to 500 range. Since the distribution is so heavily skewed, the proper measure of median is going to be 45. The proper measure of center is the median, which is 45 texts per days. This represents the 50th percentile. The proper measure of center, the proper measure of spread is the IQR, which goes from 20 to 100 and has a value of 80. This represents the spread of the middle 50% of the data. I'll repeat that one more time. The distribution of students' text per days is heavily skewed to the right, with extreme outliers of students who texted 1,000 times, nearly 800 times, and in the 2 to 500 range. Because of this extreme skew, the proper measure of center will be the median, which represents the 50th percentile of text per days, and is 45 texts. The proper measure of spread is going to be the IQR, which represents the range of the middle 50% of text per days, going from 20 to 100, having a value of 80. So think about how I just wrote some full sentences right there explaining the context of the data, because all data needs context. Who feels good on this right now? Maybe you've got some good interpretations. Make sure to cite the numbers in your interpretation. Give us those numbers. Make sure you know what those numbers mean. You don't want to just say skewed, median, 45, IQR, 80. You might lose some points on that. Give full interpretations right here, explaining with full sentences, like someone can't see the graphics and you have to paint a picture with your words. What questions are there? I think we're doing a little 474. Where's the rain, no rain video? Let me pull that up. Someone was asking about that earlier. That is a good in-depth question. Thank you so much for asking about that. We did that one yesterday, and I've got that video labeled. So if you're wondering about the rain, no rain question, that was in yesterday's morning's office hours. And we did a good, because I am ending a little early today. Here is the rain, no rain from yesterday's video. So let's put here rain, no rain. Right there, this is the rain, no rain. So rain, no rain. Thank you, Brianna, for asking about that. Rain, no rain right there in that video right there. Check it out. We'll try to do a few more new things right here. But Brianna, great question. Someone was asking about that earlier. So thank you very much. Back to the main screen. I think some 474 had questions. 474 is wondering about which ones are we going to do in 474. We can do a few right here. I try to change topic every 10 minutes or so. We have 7 and 8 for 474. Desk's shaking. 7 and 8 for 474. And I think Justin had one. 7 and 8. 7 and 8. Justin's wondering about 7 and 8 also. Can we do the 5-number summary? Oh, we do the 5-number summary. Mm-hmm. We mentioned it more specifically. We've mentioned it a little bit here. It's the min, the Q1, the median, the Q3, and the max. And that should be best used for probably skewed data. Do remember that the min and the max are going to be more impacted by outliers, because if you have a very extreme high value, that's going to impact the max. If you have a very extreme low value, it's going to impact the min. So we do use the 5-number summary sum. And so definitely, we do use the 5-number summary. The min, the Q1, the median, the Q3, and the max. And those are going to be super important when we start doing box plots here in chapter number 4. We almost got to it today. Yep, you can do it for hypothesis testing too. The null and the alternative right there. Great job, Sophie. Excellent work. We will start doing that with box plots. Box plots are going to show the IQR, and then the median is going to be at the center, and then we can see the min and the max with a box plot. So in chapter 4, we will start very specifically going into the 5-number summary and box plots. It's a very short chapter, and I'm probably going to move around assignments a little bit because we didn't do chapter 4 today. I don't like to rush topics. And so box plots coming here soon. Let's load up. Thank you so much. 20 points, all these questions, especially right here, is always a perfect time to ask questions while I'm getting stuff loaded up. Excellent time. 7 and 8. We might not be able to do all of it. We did some 8 yesterday. Let's look at 7. So I don't think we've done much 7. Now, we can't do everything right here. We try to do similar stuff. What part of 7 were people most wondering about? 474. What part of 7 were you wondering about most specifically? 474, what part of 7 are you wondering about? Let's hop in here and do new topic. 474, question number 7. Let's go do it. So right here, we have some Amazon data. This is actual Amazon data from what people are buying. So let's load in everything by going to the load above right here. That loads in everything above. You can see right here, make sure you have, I've got some ggplots in here. Make sure you have right here your loaded data. It needs to be in your files, and you'll then see that you have the Amazon data loaded in. It's in my files, so we now have the buy data in here. The name column is supposed to contain the name of the products we see right here. Nominally, before any cleaning, how many different products are represented in this data? In other words, how many different levels does the name categorical variable have? And so we go here to the buy data set, and we go to name. Now you want to be careful. Oh, we actually kind of get the answer right there. I wouldn't do it this way. Good to see you here, Frankie. This does get the answer. You could also get the answer by going here and looking at the name. And that's the way I would do it. Yeah, because you really want to be careful you don't print too much to the screen. You want to go here to something like the levels vector and look at the levels vector. And then you could go to the length of the levels vector. Excellent work right there. We kind of just did that question. I don't want to do every question, but that's the length of the levels vector, which is confirmed. Try to confirm your answers when you look at them. So have ways of reporting them, but looking at the answer also to be like, well, let's go to the levels vector, which is just the answers to the question. Good to be back. Oh, thank you so much, Frank. Good to have you back right here. That's what I think you're saying, but good to have you back. So when you look at the levels of names, what you could do, check this out, is you could make a data frame of the levels right here of name, and we just made a data frame. I want to make it into an actual data frame. Who is this calling? How did I know it's a spam call? Just got an important meeting today. I was like, I don't think it's related to that meeting. Let's turn this into a data frame. You don't have to do it this way, but I want to view this. Do you see anything? These are the names of binders. Has anyone ever... So think about if you're buying a binder on the web. Do you see anything right here? I don't want to exactly tell you the answers, but I mean, do you see anything? Do you see anything? I see something. You could go through in here. I don't think there's much too else to see. You could go through here and look at these. These all look correct. Watch me find something else right here. A bunch of Avery notebooks right there. Avery must be a big brand of notebooks. So we're actually just kind of skimming through all of them. Tons of different Avery notebooks right there. A lot of the same right there. And I don't see anything really else. I don't want to quite see the answer. But I've never heard of a certain type of notebook right there, if you see what I'm saying. Now, these are just the different names of the notebooks people have. These are just like names of notebooks. If you wanted to see what was going on right here, I guess this... don't know what's going to happen if I do this. Not bad. I actually kind of like it. This right here is just a data frame of a table. A table is a named vector, so it actually did what I wanted it to do. We can actually see that there were 280 occurrences of the 404 not found notebook. And I'm not saying that this might be able to help you answer other questions, but I am kind of saying that if you go through here, and I think, is that correct? Yeah, there we go. Oh, wow, look at that. That's a big selling notebook, the Avery Peak A-View binder. So you could go through here and probably, is it 281? I'm not saying this helps out with other questions, but I'm kind of saying if we make a data frame of this table right here, and all I'm doing is putting this inside of a data frame and saving it. This is not the answers to the questions. We were looking for what bad levels there were, and I think it should be kind of obvious. Does that make sense right there? So now you're going to take whatever bad level name there is. I don't want to quite do the whole thing. I want you to be thinking about it, because if I code it out, someone's going to write this right here and put that as their answer. That's not the answer. Not the answer. So I think sometimes people listen to these on mute. I don't know how you listen to something on mute. I think people have it on mute, and then they don't see I'm not quite doing the work. I'm trying to like show you things and maybe inspire you to be like, oh, okay, that's what the bad level is. There's only one bad level. So now we want to store it into something. So all we're doing right here is storing it into a bad level, and we're just going to take, and if there was 2, there's only 1. We would do something like this. If there was 3, there's only 1. We would do something like this. Does that make sense, Justin, right here? I think you're on the right track with this now, Justin. We're going to store that in, and it says right here, then write a command that prints out the total numbers of values in the name column, which are bad, and another command that prints out the fraction. So we want the total. So we want to do some sort of logical test. So actually we want to find out if something in vector 1 is contained in vector 2, and we could do the sum of that if we make that a logical. So you could call this right here a logical test. This is not the answer, but it's very similar. So you could store the logical test into something. We don't want spaces. And then you could do the sum of the logical test, and you could do the mean of the logical test. I'm just kind of doing it in 2 steps right here to create a logical test and then take the sum of it. So you want to see like what % of these notebooks have this right here, have this bad name, or like are multiple bad names. And there's a lot of ways to do this, because you could just use like a table or something. Like this whole thing could be achieved by a table. It's just an interesting way to do it, because there's always multiple ways to code things. Given the table, produce a vector of the integers that give the frequency of the unique values. Much like a column of data frame, each element in the vector of the output table is given name corresponding. These names can be extracted by using the names. So anytime we do a table is a named vector. So you can go right here to the names of a table. I always put name and then it messes up. And here's the names of a table. I think there are just more things in B, and I don't know where else to look. With the B right here, you are doing things. What's B say? I don't think they're able... Yeah, oh, there's just the 1. There's just the 1, yep. And then if you make the table, if you make this right here, you can actually see what's going on with this right here. That one right there. Is that making sense for number 7? We might hop back to do a little 320, 474, 475. I'd like to spend about 10 minutes on each thing. But I think number 7 should be making more sense right here to everybody. I didn't quite do all the work. I don't want to always do all the work for the question. But are you feeling a lot better about number 7? Makes more sense on what we're asking. and making these tables, extracting the names. I didn't do all the work right here. Awesome. Want to get you on track, get the work going for it, and that's got it. It's open floor for questions again. If there is no questions, we will come back and do number 8. Let's go back. Open floor for questions. I'm going to try to jump to a different class right here for 201, 320, 475. It's your call right here. It's open floor. Caroline, great job. Let's throw Caroline some more points right there. Caroline, great job on those points. We'll put 30 seconds on the clock. We're going to do 475, question 8. Talk about that a little bit here. If there's no choices, we will do that next after this. 30 seconds on the clock for you to pick a topic. You're welcome, Caroline. Great job. If you're like, hey, 201, could you explain this? Any topic right now, you can pick. Your choice to pick the topic. Meeting in 35 minutes. Whew. Exciting meeting today. Oh, that's it. We're doing some question 8. Question 8. Here we go. Question 8, new topic. Question 8 for 474. Question 8, 474. So question 8 for 474 is about constraints, and this is for data validation. What does it mean to validate data? We're doing CDF and PDF at any point. We don't actually do that. You can do the normal CDF and the normal PDF in the apps or in the TI calculator. So, and actually, you know what's interesting is that's what I was doing right here with the Q norm and the P norm. You can do stuff like, so watch this, Q norm. You can see all the different commands right here, and you can see how it's being used for the density and everything. So we actually do this sometimes in upper level classes. We always go for the application purposes of it, but these use the functions right there, the CDF and the PDFs. We don't go a lot into CDF and PDFs. So that's a little bit more mathematical. Great question, Sophie. We kind of focus on the more business and application side. So we do a lot of hypothesis testing, a lot of confidence intervals. And you can kind of see where this is going because this right here is one of our upper level courses. So good question, Sophie. This is where we're looking at the data and we're going to validate it. So think about this. Someone is buying a notebook. And the way Amazon works is there's like a bidding on it. Like they have a certain price that's a low price that they'll put out and a high price that they'll put out. So they're going to have these different prices that just kind of adjust, like the lowest price they put and the highest price. And we're going to store this. Oh, yes, Edgar, we could do that next right here. You got it. So let's look at this one right here. So this is the price we see for notebooks. And we have the lowest price the notebook was at and the highest price the notebook was at. So think about this. You go and you collect a bunch of data on notebooks. You have the lowest price and the highest price. What should low never be? So if we have a violation where this data just doesn't make sense, the price of a notebook, we picked the perfect one then. 8B. We'll come back to that here. Is this not 8B? Oh, this is 8C. Oh, we'll do this and we'll come back into that right there. So the price of a notebook should be somewhere between these two values. Does that make sense right here? The price of a notebook should be somewhere between the lowest price it was at and the highest price it should be at. If it was outside these ranges of the lowest possible price and the highest possible price, that's data that's just incorrectly collected. And this is just the world we live in where people collect data the wrong way. So let's go ahead and add a chunk right here where we can write code, and let's just call it 8C. I think this is 8C. So we want to look at the price a notebook sells for, and we want this price to be what? So Justin, figure this out right here. We want this price to be what? How could we write this right here? We want this price to be what? We'd really like for this price, because if it's good, like we have the right price, whatever price we should see for a notebook should be at least what? How would I write this as a condition? It should be between those. Great job, Evan, right there. It should be between those, as in it should be greater than or equal to the lowest price. And we can check this. And it should be, the price should be less than or equal to the highest price it's sold for. So I'm seeing if it meets these conditions. Ooh, what we got here? What do we got here? These falses right here are notebooks that has a price that is not, and that might be the first, I think it's the first one, that the low is less than or equal to the high. This is that the price that we saw the notebook sell for is greater than or equal to the lowest price it had, and is less than or equal to the highest price. Like it's between, like we have a low price for a notebook and a high price for a notebook, and then the price is somewhere between there. Like it's not outside that range of the low and the high price. So we want to see this, that the price is somewhere between here. So if it is true right here, does it meet the condition or violate the condition? Oh, no, you're right. You're right. That was the first one I think you were looking at. If it is true right here, does that meet or violate the condition? So think, is this a good thing or bad thing if the price is greater than or equal to the low and the price is greater than or equal to, less than or equal to the high? Is this true a good thing? Is that meeting the condition or is that violating the condition? So this is like data validation right here. So this is, we're working at a company and they're collecting data. And so there wouldn't really be a null right here. This is like, is our data correct? Someone's telling me that the price of this notebook is higher than the highest price we have it listed for. Like the highest listing price is $8 for this notebook, and they're saying it sold for $8.50. Well, wait a minute. The notebook shouldn't be selling for $8.50 if the highest price is $8. And so this wouldn't really be rejecting the null. It would be, it's not accurately collected. Exactly. Sophie, 100 points, following along with some 474 right here. So this is when we would say, your data is just wrong. Your data's been incorrectly collected. Like this is data validation right here, which is a big important part. So this would violate it right here if it's outside it. So we want to see if these things are inside this range, which is a good thing. And this is where we do a simple little thing. And who knows what I'm going to do to flip these trues to falses and falses to trues. So now we have something meets the condition. How do I write not meets the condition? So all these things right here tell me if it meets the condition. How do I change this to it does not meet the condition? Boom, right there. That's all we put. And now it just flips my trues and falses. So you can see right here, not true is false and not false is true, but it's just doing that to the whole vector and just changing everything. So now we can figure out what % of things are violating the condition. We just throw a mean around that. Oh, we have NAs. NAs are missing this. We don't have data on some of the records. So we have to do this right there. And I did that earlier in stats when I changed it to decimal places. I have to change my options back to options digits equals 7. Okay, now it doesn't look so ridiculous. But you can get such decimal place accuracy, which is so nice. And then you can control for how many decimals you get. Be like, change my output to this. Remember, you don't have to write these things I'm writing unless you've been changing around your R. But now we can see that there are 14,672 observations in this data set that violate the condition. So something's collected incorrectly right here. And 15.37% of our data also looks to have validation issues. So this is a problem we need to talk to the company about and say, you got some issue with how you're collecting your data, which we always like to say junk data, junk results. So one of the big concerns with analytics is your data accurately collected? Because you must first accurately collect data, make sure it's the right, you're actually getting good data to then be able to analyze it and get good results. So we haven't really done much analysis. We're just doing what is called data validation right here. And we'll look at one more data validation right here. Define price fixed to be a vector that contains the price right here. So let's go do that. All we're going to do is just define this as it contains the price. There we go. We just created that. Let's get rid of some problem values by performing a simple median replacement. So we're only going to do the first one right here. We're just going to do the first one. I'll do the first one. Replace all values in price fixed that are 100 or greater. So this is a notebook right here, I think, that is selling for more than $100. If you went into Walmart and you saw the price of a notebook was this, what would you think? You walk in, you say, let's go buy some notebooks. You see that for your price of your notebook. What are you going to think? You walk out down the aisle and it says $190 for a notebook. And you're like, what? 4B, we could do that next year. You got it, 4B? Great question. What would you think if you saw $190? You'd be like, I'd leave. You'd say, no more Walmart. I'm out, Walmart. Sorry, Walmart. They maybe meant $1.90. So the goodness fit test, the goodness fit test tests the distribution. I'm trying to see how that relates. But goodness fit test is a test to see if a distribution fits, and the higher the p-value, the more likely it is by random chance that the distribution is the correct fit, and then the lower the p-value, the more evidence we have that what we are observing is unlikely given that distribution is the distribution. I'm trying to connect the topics, but no. Goodness fit test for testing to see if we are using the correct distribution. And this is just data validation right here. Because think about this. We have prices of notebooks right now. Let's look at the prices of notebooks. And this is good right here. Check this out. 5-number summary. There was a notebook selling for $989. Here's the 5-number summary, the min, the Q1, the median, the Q3, and the max 5-number summary right there. So you can see, yep, exactly. So we could see, great. We could test the distribution of this. We could actually do that pretty quickly right here with this Shapiro-Wilk to test to see if it fits the normal. Ooh, it doesn't like the sample size. So let's go to the price and go to sample and let it take. It's saying it's too big. Shapiro-Wilk won't work for that. And there's the omnibus test for normality and stuff. Size. Wait, where am I inside the sample right now? I left the sample. I'm going to take a sample of this and sample 5,000. It's saying it's not normal. And so there's the shape of it. Oof, that's not normal. And you can tell from looking at the shape of that this is not normally distributed data. It's a very, very right skew distribution. So using a goodness of fit test right here, good topic to talk about, we can tell that this is definitely not normally distributed. We don't really need to sample it. It's just that the Shapiro-Wilk won't let us do it for that large a sample size, probably because of the false positive rate. But this is definitely right skew, right to the high, left to the low. This is definitely not normal. And so it's very unlikely, like basically impossible that this came from the normal distribution. And also, a big issue we have with this data right now is I'm telling you that a notebook at Amazon sells for $989. How about we find these notebooks that have a price greater than or equal to 100? Oh, we might have enough time. We might. Kylie, great question right there. I think that's next after the 320. So how can I find out? So take a moment right here, 474, 320. Write a condition right now to figure out if the price is greater than or equal to 100. Because we're going to try to find the values that are greater than or equal to 100, and then we're going to replace those values with missingness. We're just going to delete those values. That's what missingness is. These NA values right here are just the values don't exist. We're just going to say, like, if it's greater than or equal to 100, we're going to say that's just a no. And Justin, great job right there. We're going to say greater than or equal to 100. This is a logical test. Look how we get some NAs right here. And let's go here to the which is going to tell us the positions. Oh, it's only one notebook. This is the notebook that's sold for a ridiculous amount. I'm going to store this in here as positions. Then I'm going to go to, let's go here to price fixed and go to position. This right here and store into this NA. Now, currently, before I run this code, it has the price of that. And now when I run the code, I've deleted it because I've stored into it NA. I've said this value of $989, I don't want that to exist. If I had searched for like values over like $10, I'd get a lot more positions. Now, don't do this, but these are all the notebooks that sold for more than $10. Maybe it's a really cool notebook. If I saw a notebook for $12 at Walmart, I'd say, okay, I guess that's just an expensive notebook. I wouldn't think, oh my God, this notebook is over $100, which is ridiculous. And there's only one, so we're removing that with an NA right there. So now when you think about this, you probably, and I'm not saying this is the next part, but you probably want to find where things are NA in the price fixed vector. So these are the positions of things that are NA. If you notice, we're just doing a similar code right here to find the positions of things that are NA. Discussing words, where we're seeing on the mosaic. Oh, we should do, yep, I think we're going to do that after the 320. You got it. We have just enough time for both those. Justin, how's it looking on this right here? I'm going to probably stop working on this one, but this should be a good bit of like getting that engine going on number 8. Number 8. Does that make sense here for number 8? How to kind of find where NA is at, find the positions of the NAs. Remember, is.NA is a logical test to see if it's missing, and then we probably want to go find these positions and store into these positions. Yep. So once you then find these positions, because this is what is missing, what positions are the missing? Hello? I hear weird noises. That's got it right there. We'll head back. Let's do 320, and then let's do some 201. 320 was asking the question, and we'll do 201 right after this. I think we're going to do some visualization number 3. Can you go over how to do 4B? Let's go check out some 4B. Thank you so much, everybody, right here. Great office hours right now. I am ending a tiny bit early today. Got a big meeting. But really great stuff. And we do have a review night tonight for 320 and 474 review night. 7A, I might have it, because today is right skewed. It's nonlinear. That is if you're doing bivariate relationships. So if we wanted to do, it's a great question right there, Sophie. Just doing the univariate relationship, we'll look at shape, center, spread. 201, shape, center, spread. But when we go into a bivariate relationship, probably we'd be doing like nonlinear regression techniques, such as transformations or fitting a polynomial model. So, man, Sophie, you got so many great questions, right? No, I love it. Have you taken stats courses, Sophie? Because that's where we would say, okay, if we're looking at a bivariate relationship due to kind of the non-normal relationship, at that point, we want to have a linear relationship between the x and the y, and we want to make sure we have homoscedasticity versus heteroscedasticity. I can't say those complex words. And we would want to analyze the bivariate relationship. Let's go check out 4B right here for 320. Great questions today. Yeah. Oh, that's great. No, you definitely know it. And you are asking some great questions. And what's interesting, I really like this because some people just, stats is very mathy, and then business analytics is very much interpreting it. So is self-teaching detail. Oh no, I'm so sorry. Keep asking those questions, Sophie. You're asking amazing questions. Hence, I just tossed out some points. So let's look at this right here. What percentage, and this is a very similar question, what percent, a number between 0 and 1 of alumni have donated to UT? Two ways of approaching this. We can use the length which, but I hate that. I hate using the length which because watch this. If we look at the alumni, and I need to load it up, make sure you have your data already loaded in. Now it'll run. And I look at lifetime gift to UT. Here's how much people have donated. And I want you to think about this. What did I just find right here? Which we could also find by doing a summary. I just found the what, which is crazy awesome. What did we just find? And that's where the $48 million. That's the maximum gift. Now, if we want to know who is this, we could go here to which.max, hint, hint, hint for other questions. This is the which max, the highest lifetime gift amount. This is the person. And you go here to alumni, and you go right here, and you can see right here the information on them. They got a bachelor's of science. They were in finance. 865. They are the founder and chairman of something. This is real data. They are the founder and chairman. Their graduation year, all this stuff right here. Yep. Lifetime gift, 1978, all these different things. 1952 graduation year. Yeah. So huge thank you to our donors, and we really mean it. And we like to work with real data right here, but just think this is real data. These are lifetime gifts and everything. So working with real data. Kruskal Wallace, oh my gosh. Yep, for non-parametric or for skewed data for medians. Yes. Yep. And the Kruskal Wallace is going to be the ANOVA for multiple groups. Wow, great job right there. That is analyzing differences between medians right there. The Max donation. Colin, so good to Colin. We gotta talk. I'm just so busy these days. Learning R really helped me with a recent big project we just pushed live. Yes, maybe that's what you're going to tell me about. And so now, how about we go here and we see if somebody's lifetime gift to UT is greater than or equal to 0. I just want you to think, what am I finding right here by looking at this? By seeing if somebody's lifetime gift to UT actually is greater than 0. Everyone's gift will be greater than or equal to 0, which actually would be a good data validation. Talking about data validation again, you don't want to see that somebody's lifetime gift to UT is less than 0. Good. If somebody's lifetime gift to UT is greater than 0, finding who has donated to UT because they've given to UT, their lifetime gift to UT is greater than 0. Does that make sense when we read it? Like in this data frame right here, which looks just like an Excel spreadsheet. If you go look at this, it's just like an Excel spreadsheet. All we're looking at is somebody's lifetime gift to UT. Lifetime gift to UT is going to go find it. Oh no, we're finding the rows right there. Looking at their lifetime gift to UT, it's somewhere in here. Their lifetime gift to UT, is it greater than 0? So we're just finding that out right here. Here's all their lifetime gifts. You can see we're just going to find out true or false. They have donated more than 0. And then guess what we can do? We can actually add up this because I want you to know this. This is very important. How does R see trues and falses? How does R see trues and falses? Bonferroni. Oh, yes. How does R see trues and falses? It's ones and zeros. So we can sum them up. And we can also go right here and take the mean of it. Bonferroni is going to be used for multiple tests. Bonferroni correction right there for multiple tests. So you did some really good stuff. That's going a little bit advanced right there. So it was an advanced dual stats in high school. Oh, for like, yeah, it was like maybe a college dual stats, because Bonferroni sounds a little bit beyond like AP stats even. The Bonferroni test right there for the correction, Bonferroni correction, right? I just usually think family-wise alpha correction. All statisticians love to put their names to it. I think we just did parts of that. Check out a little bit earlier, Cora. Check it out, because I think we're going to hop here for the end of this and do 201, interpreting some mosaic plots. 5A, I think we have tough time here to do 5A for 320. Is it 5A 320? And then we're going to try to do 201. Is it 5A 320, Matthew? Thank you so much for all the questions. I think we have here 5A for 320, right? 5A for 320? Okay, let's do that. And then we're going to do the 201 to end. And 7A, we might not have... We might have done 7A in another video. I think we did. We'll have to check that out. We're going to do 5A was another way, a Nova test. Yep. I think the Bonferroni, you're talking about like, because when you do an ANOVA test, it's a post hoc, right? NF test, yep. Bonferroni is going to be a post hoc, a test afterwards. The Bonferroni, it's a post hoc, I believe. Yeah, awesome. Email me if you can't find something. I'll try to find it for you. That's a good way right there. Let's go check out 5A right here, and then we're going to do some 201. Awesome office hours today, everybody. Awesome office hours. Let's do a little 5A right here. So we're actually working with the Greek vector right here. So there's a column called Greek. How do I get to the columns inside a data frame? It's good practice. How do I get to a column in a data frame? These are things we need to know pretty quickly, just with lots of practice. How do we get to our columns in a data frame? So how do I get to a column really quickly? Great job right there, Sophie. 20 points, everybody. How do we get to columns in a data frame? So if I go to a data frame, it's just an Excel spreadsheet. Just think like, oh, I'm in an Excel spreadsheet. Okay. How do I get to those columns, those vectors? Because I want to go to the fraternity sorority vector in the data frame. It's just a vector. It's just a column of data. How do I go get to that? Matthew, you're right. Great job, Matthew, right there. And you notice it starts auto-completing. Whoops. You got to hit enter. There you go. Now we have the fraternity sorority vector right here. And then we want to take it and we want to store into Greek. But we want to append a column, which means we're going to go to alumni and we're going to add this. Now I want you to see down here, Greek is not at the end of this until I run this. And guess what? Now Greek is at the end of it. You can call this anything you want. Anything you want. And it will append it to the data frame. Now, you don't want to call it anything you want. And there it is. But whatever you call something, if it does not exist, it'll create that vector in a data frame. You probably don't want to call it that. But here we are. I just like to do fun things. So we have right here the Greek vector has now been put into the data frame. So let's do a little bit more. How many levels does this have? Ooh, we were doing this earlier. 474 knows about this. I think it was Justin was doing this. Because now we want to go to the levels vector and we want to get the what of the levels vector. I'll do two more parts of this. We want to go to the levels vector and get the what of the levels vector. So we want to go to the levels vector and then get the what of the levels vector. So I think we got to go to the levels vector. Okay, the levels is just a vector telling us the different levels. These are the different responses. Someone says, I'm in Zeta Alpha. And you say, okay, cool. And these are not how many people responded. It's just like freshman, sophomore, junior, senior. If we get the dim of this, that might actually do it. That might actually do it. It's null because it doesn't have dimensions. If we do sum, I don't know I'm going to do it. It says nope. It says nope, no. And always try this. Just try this. Try your things. Well, I can see the answer to the question. That is the what of this vector. So remember, we just got a vector, and 65 is the what of the vector. It's how long it is, so it's the what of a vector. It's how long it is, so it's the what of the vector. It's how long it is, so it's the what of the vector. I thought dim might work. I had hopes for dim. It's the length. Boom. There we go. It's the length of vector. Great job right there. 50 points following along. So that's how many possible answers there are. Now, that's not what people answered. If we want to know what people answered, we'd have to actually make a table of responses, and then we could see what people answered, and it's pretty large right here. Let's do the following. Let's just store it as a data frame. So data.frame, Just for viewing purposes, we're doing this. This is not your assignment. Not your assignment. We're just doing this for viewing purposes right here. 10 minutes till meeting. So, ooh, what's this? This right here is the first level. I'm kind of giving some hints for this. If we go look at the levels vector of this, the alumni, $, Greek life. If we go look at this, the first level is actually that. When I think size, I think dim. Sometimes it works. For data frames, it works. It'll give you the dimension, like how many rows there are. It will actually work on this one now. This is basically the remaining answers and kind of how to work them. Do you notice how this right here is not quite blank? It's a what sort of thing. This right here in R, because it has quotes, it's a quote with nothing in it. This is a what thing right here. A quote with nothing in it is actually a what. Like this is still this, but it has something in it. So this right there, which is what this is, it's got nothing in it, is a what. How is R seeing this? It's a string. Great job, 20 points right there. Great job. That is a string with nothing in it. It's like a word of nothing. Weird, right? Down here, we see some other weirdness. I mean, I'm not saying this is answers, but someone replied, UT Kappa Sigma, UT Kappa Sigma, UT Kappa Sigma, UT Kappa Sigma. And you're like, what the heck? I thought I made a full table. Oh, I made a table of this. If you want to see how many people responded with different things, here's how many people responded. So these are the amounts of the responses, and you can even sort this pretty quickly right here. And this is a frequency table for 201. So you can see we do have some people who responded some pretty crazy stuff. Like someone replied that they're in Phi Kappa Delta, Phi Kappa Delta. There were 3 people who replied this. So we do have some weird stuff going on with this data, hints for later on. Are people doing better here? We're going to try to do a little 201 to end. But how do people feel about this question right here and understanding? Awesome, yep. And that's the goal. I kind of just want to be like, so you can understand what you're seeing with the data right here. And remember, I don't quite do the questions. I kind of give some hints for them. Let's hop back here and do some 201 to end. A lot of people are wondering about visualization number 3. So do remember we have the visualization playlist. I'm probably going to put that in the chat here at the very end because I'm going to hop to a meeting soon. Visualization 3. So 2 seconds. I'm going to put this in the chat right here. Long hair Brian teaching some visualization 3. You are welcome, Matthews. Thank you so much. So as outliers skew the data, if there's enough, then the data is unreliable. The mean would be unreliable. The mean would be unreliable. So we'd want to use the median. The measure of center is best used, mean or median, depending on the shape of the data. So if we have normal data, we want to use the mean. If we have skewed data, we want to use the median. So we always look at the shape to start, and then we say, oh, this data is really skewed. So we will use the median instead of the mean. Great job and great practice. The measure of center is best decided by the shape of the distribution. Visualization 3 coming up right here. Let's check it out. Yes, exactly. Great job, Sophie, right there. Yep. Because variance is a measure created from the mean. And so variance would also be unreliable. So standard deviation is unreliable because standard deviation is square root of variance. Great job right there. Excellent work. So we have right here, I'm putting the video in the playlist right here for the another help video. We're going to be making mosaic plots and side-by-side box plots. Side-by-side box plots right here. And when is this one due? This one is due on September 3rd. So I think I'm going to be pushing this back right here to next week. So we don't have these side-by-side box plots right here. I don't like that we put both of these because these are 2 bivariate displays right here. We did the mosaic plots today in class. So if you're in the afternoon class, let me know. I need to change this for both classes. 2 seconds right here. We're changing due dates. I thought this only had mosaic plots. So 2 seconds, longer due date, visualization 4 right here. So let's go here to bivariance. And we're going to edit the due dates on this. The other one's due on the 10th. And let's go down here. And that's due on the 10th. So we're going to put this due on Wednesday next week. And we will be covering it on Wednesday. And I'll probably even do some of it in class. So if you're worried about this, this will be covered on Wednesday, just pushing it back. We're going to talk about whether data is statistically significant. Yep, definitely. With when we do a statistical test, definitely. I just joined, but I want to start at visualization 2. Have you guys gone over visualization 2? We did that in the previous video. I'll put that in the chat. We're going to talk a little bit about visualization 3 before I have to head off here real quick. Visualization 2 can be found in the following video. Let me send you, because I have to leave here in 5 minutes. Visualization 2 is right. I'm going to send you the playlist where I'm not the playlist. Visualization 2 is right. Why can't I find it? I believe it is this one. Nope. 2 seconds here. Brain boot up. Oh, because I moved the video over. All right, here is visualization 2, and we do a long walkthrough of it. And we'll probably be doing visualization number 3, a long walkthrough of it. You know what I might do? I might stream visualization 3 tomorrow. Correct. 0.05 is the cutoff for statistical significance. Let's see. We've done the mosaic plot today in class. Here we'll show how to make a mosaic plot and a box plot. We might not get into the full interpretations. So let's go through it here over a mosaic and a box plot right here and talk about how to make these. Let's download the data right here. Make sure you have Jump working on your computer. Open license. My Jump is being odd lately. I have to load the license every time. I'm going to reload Jump this weekend or maybe tonight when I get a chance. So here we are. Jump is now loaded up on my computer. I swear I have Jump installed. And here is the data right here. Now, when we do mosaic plots require what types of variables? Mosaic plots require what kind of variables? 2 categorical variables. When we do side-by-side box plots are also bivariate. So if you notice right here, we have categorical, our mosaic, and side-by-side box plots are quantitative categorical. So let's check this out right here. Oops, wrong buttons. Let's check this out right here and go and make, and this is not quite your assignment. Great job right there, Sophie. We're going to go here to analyze fit y by x. Analyze fit y by x is going to allow us to do bivariate relationships. And we could see, let's look at somebody being born in Tennessee. Does that explain their relationship status? So we have here, we're going to get a mosaic plot because we have categorical. And so here, and it doesn't look like there's much of an association. It's a rather large graphic, but you know what we could probably find an association with? Let's look at one where there is one. Let's look at somebody's gender right here and if somebody's broken a bone. Once again, categorical. And now we see, and we can look down here at the bottom. You can remove some of these if you want. Like if you want to remove the total, maybe we want the total. Make sure, I'll be going more in depth on this next week. Make sure to have the right percentages, but notice how if somebody is male, they are more likely to have broken a bone. 54.65% of males have broken a bone. And I think we want the row percentages, actually. I'm doing it by memory right now. 54.65% of males have broken a bone, as opposed... I'm never going to hit that button. Can I delete it? Nope. 54.65% of males have broken a bone, as opposed to 40.13% of females have broken a bone. Watch out if your graphic were to get a little bit cluttered like mine. You probably wouldn't want these directly over your graphics. So for interval regression, it's quant. And 2 quantitative variables for regression right there. And if we want to do side-by-side box plots, we would go here to the same. And I think we're doing it via Graph Builder. We're going to go to Graph Builder, and we could look at the GPAs of students by going here and putting gender down here. What could I use to print a specific value given certain conditions? Edgar, email me and we'll double check. This is how to make side-by-side box plots right here. And look what we have. We have the 5-number summary. Is this going to give the full summary? Ooh, we don't want that. None. Go back to this. We should have to give the 5-number summary. Where's my 5-number summary button? Let's go to box plots and then let's click the 5-number summary. Here we go. Box plots. There's my 5-number summary. Boom. And we will go over this more in depth. I have to head out in just a moment here. But this is a side-by-side box plot where we have somebody's gender right here. And then we have their high school GPA. And we can see Probably me bringing down the GPAs of the males right here, but this is it. Min Q1, there we go. Min Q1, median Q3, max. After finding out the problem in the graph, and then we have right here. We won't draw box plots, but we'll practice them and know how to interpret them. More on visualization 3 tomorrow. Stay tuned. We will have a full walkthrough. I moved back the assignment. I suggest doing it this weekend, but I will have a full walkthrough. I'll be back, everybody. I have a meeting. I'm so sorry. We'll be back here on Stat 201. Bye for now, everybody. Bye. I'll be back, I promise. Sorry for ending early. I still have some points. Points, Puppet Shark.